Hi, Asia. My name's Ellsworth, and I took your problem as a challenge because it has a lot of moving parts to it, but we can make them sing together. It's going to go kind of fast, so buckle up, and here we go. There's your problem. You tell us what the temperature is using a sine and cosine function. The high is 67, and the low is 39. It occurs at 3 a.m. So it assumes that T is the number of hours since midnight. Find the equation for the temperature D in terms of T. Okay, let's figure a few things out. First, we make some assumptions. One is the day is 24 hours long. That'll be a period of our function. Every 24 hours, the temperature repeats. Next, low temperature occurs at 3 a.m. because they told us that, and it's 39 degrees. Now, assuming a periodic function, the higher temperature occurs half a period, or 12 hours earlier, which is 3 p.m. rather. So the high temperature is 3 p.m. at 67 degrees. Okay, the general form of the function is this. I use T, apologies for that, because T is the temperature, because I need A, B, C, and D for these variables here. So here are all the parameters you need to work on. A, B, C, and D. A is the amplitude of the wave, B is the frequency, C is the horizontal shift, and D is the vertical shift. How they all play together, you can see that picture right there. So we need to find A, B, C, and D. Well, look at the first two, pretty easy. A is easy. Take the high and low, subtract them, divide by 2. How high is the wave? It's halfway between the highest and lowest. High 67, low is 39. That's a 28-degree difference. Divide by 2, so it's 14 degrees. So the amplitude of our wave is 14 degrees. And here's a picture that I'll be updating as I go along here. Here's our sine wave, and we can see in that picture that we found that the amplitude from the center line is 14 degrees. Speaking of the center line, where is that? Glad you asked. That's our next thing to figure out. Okay, we can use a very simple calculation to figure out where the center is. In a pure sine wave, the center line occurs at y equals 0. Well, here the center is halfway between the high and the low, 67, 39, divided by 2, 53 degrees. Okay, update our picture, show that. Now, how do we know we're doing all right? Find the high and low, put our equations up there, and you can figure it out. So far it behaves correctly. Next part, frequency. Our period 24 hours, divide that by 2 pi, you get pi over 12. So our frequency is pi over 12 cycles per second. So, update our formula. There's pi over 12. For the last part, Okay. Last part, phase shift. You gotta make everything line up. We're at 24-hour clock. So we sweep our 2 pi radians 24 hours. Line everything up. Our 0 point is at t equals 9, based on a few calculations. So to make everything inside the parentheses 0, you have to make 9 minus t equals 0, c being 9. So put it all together. Your final equation is t of t is 14 times sine pi over 12 times t minus 9 quantity plus 53. So I say you may need to watch this again, but all the pieces are there. Happy figuring.